This video is for the 3 questions under the heading 7.9c. Determine the area of composite figures containing combinations of rectangles, squares, parallelograms, trapezoids, triangles, semicircles, and quarter circles. Okay, so let's read the question and see what it asks us to find. It says that, question number 1, the park modeled below consists of a rectangular area and a semicircular area. The area of the rectangular part of the park is 60,000 square yards. Our question states which of the following is the closest to the area of the entire park. Okay, so let's annotate this for information. All right, it tells us that we have a rectangle and a semicircle in my park. The area of the rectangular part of the park is 60,000 square yards. And we're looking for the closest to the area of the entire park. Okay, so you have a composite figure here. So you need to decompose the figure, and then you're going to your formula chart to find the area formulas for both shapes. Okay, so when we decompose, I have a rectangle and a semicircle. So pause the video, go to your formula chart, and get the areas that we are going to use for both of these. Okay, so on your formula chart, the area formula for a rectangle is base times height. The area for a circle is pi r squared, but since it is a semicircle, I am going to need to take that formula and divide it by 2. Okay, so now, I have the formulas that I'm going to use. Now let's get the information. It tells us that the area of the rectangle part, so I already have the area, is 60,000 square yards. So that means that I have to find the area of the semicircle. Before I can do that, I have to find this measure here, which is the diameter of the circle. Okay, so I have a missing side. I'm going to work backwards from the area formula of a rectangle to find my missing side. So I know that the area of the rectangle is 60,000. It is going to equal my base, which is 300 yards, and I need to find the height. Okay, so this equation here should look familiar to you. I want the h by itself, so I'm going to divide both sides by 300. When I do that, the 300s on this side, on the right side, cancel, and I am left with h by itself, which is what I want. When you have this set up here, you can take out your zeros 1 for 1. And so now I have 600 divided by 3. When you go 600 divided by 3, 3 goes into 6 twice. When I multiply, I get 6. When I subtract, I get 0. So I'm going to put another 0, and then one more 0, for there are 2 remaining zeros in 600. So my h, my height, is 200 yards. There's my missing side, or my diameter. So my diameter is 200 yards. Okay, so now I'm ready to work the area of the semicircle. I am given diameter. My formula works with radius squared. So I need to find the radius, which would be 100, because remember, radius is half of the diameter. And then I need radius squared, which is 100 times 100. And so my radius squared would be 1 with 4 zeros. And so my radius squared is 10,000. This is what I'm going to use in my formula. Okay, so now I'm going to work the area formula of the semicircle. Pi, and I'm going to estimate pi for 3. I'm going to use 10,000 for radius squared. And I'm going to take all of this and I'm going to divide by 2. 3 times 10,000 is going to give me 30,000. And when I divide this by 2, I'm going to get the area of that semicircle to be 15,000. Okay, so now I have the area of the semicircle at 15,000, but it's asking for the closest to the entire area. So your final step would have been to add the 15,000 to the 60,000, and so it is about 75,000 for the total area. You would have seen that on B, so your answer for this one is 75,700. The reason there is a difference in what we solved in your answer choice is because we used 3 for pi and not 3.14. All right, if you have any questions with this question, please see me. Question number 2 states, one of the tokens for a board game is a circle containing 5 congruent triangles as modeled below. Which measurement is closest to the area in square centimeters of the token not covered by the triangle? Okay, so let's annotate for information. We have a board game, it's a circle. Okay, so the whole shape is a circle, and I have 5 congruent triangles. Remember, congruent means that they are all the same. My question states which measurement is closest to the area of the token not covered by the triangle. So I want the area of the circle. Again, I have a composite shape, so I need to decompose it. I have a circle, and I have triangles. So pause the video and go to your formula chart so that you can get the area formulas for both of these shapes. Your area formula for a circle, you should have written pi r squared. The area formula for a triangle is 1/2 base times height. Okay, so I'm going to work the triangles first. I need to find the area of one triangle and multiply it by 5 because I have 5 congruent triangles. All right, so I have a base measure of the triangle of 1 and the height measure of 1. And so when I multiply those together and divide by 2, I get the area of one triangle, which is 1/2 centimeters squared. Okay, so each triangle is 1/2 centimeters squared. And so when you have 5 that are all the same, you can multiply this by 5, which will give me 5/2, which means that my area of the triangles is 2.5 or 2.5. Okay, so that's the area of the triangles. Now, I need to use that information after I find the area of the circle. Okay, so I'm going to find the area of the circle. I'm going to use 3 for pi. But now I need to find radius squared. You have to make note of this line up here. It is showing you that from one side of the circle to the other side is 6 centimeters. That is your diameter. If my diameter is 6, my radius is 3, but I need radius squared, which is 9. Okay, so I have 3 for pi, 9 for radius squared. So the area formula for the area of the circle is going to be 27 centimeters squared. Okay, so I have the area of the circle of 27, the area of the triangles is 2.5. Since they are sitting inside the circle, remember you have to subtract the area out. So I'm going to subtract 2.5, and remember when we add and subtract decimals, we have to line them up. So I'm going to subtract 2.5 from 27. You can't take 5 from 0, so I'm going to make it a 10, and I'm going to regroup the 7 to a 6. 10 minus 5 is 5. I bring down my decimal. 6 minus 2 is 4, and then 2 minus 0 is 2. So my answer is about 24.5 centimeters squared. So looking at your answer choices, you have to remember that we use 3 for pi, so my answer needs to be a little bit more than 24.5, and that would be J, 25.76 centimeters squared. If you have any questions with this question, please see me. Okay, Okay, the final question under this section, question 3, states, Amanda drew a cupcake from a semicircle and a trapezoid. She colored the entire cupcake pink. What is the area of the cupcake she colored pink? Okay, so since we're going to annotate for information. Okay, so I have a semicircle and a trapezoid. She colored the entire cupcake pink, and I am looking for area. Okay, so I have a composite shape. You need to decompose. It has a semicircle and a trapezoid. Pause the video and go to your formula chart and find the area formula for both of these shapes. All right, we have an area formula for a circle, pi r squared, but since it is a semicircle, I am dividing that by 2. Your area formula for a trapezoid is base 1 plus base 2 multiplied by the height and divided by 2. So those are the 2 formulas you should have written from your formula chart. Okay, so let's start with the semicircle. All right, I need to know, what did they give me in my circle? I have this measure here of 8. That is your diameter. If my diameter is 8, my radius is 4, and radius squared is 16. I'm going to use 3 for pi. R squared is 16, and I'm going to divide the whole thing by 2. Okay, so 16 times 3. 6 times 3 is 18. I'm going to bring down, put my 8, carry my 1. 3 times 1 is 3, plus 1 is 4. So it's 48 divided by 2. And so area of the semicircle is 48 divided by 2. 2 goes into 4 2 times. When I multiply, I get 4. When I subtract, I get 0. Bring down your 8. 2 goes into 4 8 times. I'm sorry, 2 goes into 8 4 times. 4 times 2 is 8. When I subtract, I get 0. So the area of the semicircle is 24 centimeters squared. Okay, so I have the semicircle. It is 24 centimeters squared. Now I have to come find the area of the trapezoid. Okay, base 1, and remember, it doesn't matter what you call base 1 or base 2. You just have to use the 2 parallel lines. So my base 1 is 8, my base 2 is 6, and the height is 4. And I'm going to add all that. I'm going to add 8 and 6, multiply by 4, and divide by 2. So 8 plus 6 is 14. 14 times 4 divided by 2. And so now I have to do 14 times 4. 4 times 4 is 16. I'm going to carry my 1. 4 times 1 is 4, plus 1 is 5. And so it's 56 divided by 2. 56 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. When I subtract, I get 1. I bring down the 6, I get 16. 2 goes into 16 8 times. 8 times 2 is 16, and it will terminate. And so my area of the trapezoid is 28 centimeters squared. Okay, so this is the trapezoid. I have the semicircle, so now I'm going to have to add these 2 numbers together because they said the entire cupcake was painted pink. 4 plus 8 is 12. 2 plus 2 is 4, plus 1 is 5. So it's about 52 centimeters squared. Now again, I use 3 for pi. So that means that I am looking for this answer or something a little bit more for 3.14. You're going to see the little bit more right there with D. So your answer on this one was D. If you have any questions with any of these 3 questions, please see me. Thank you.